The following content has been provided by RWTH, Aachen University.
Hello, everybody. Today we are going to do, first of all, a demo presentation for what we will expect from you, similar to the things, so you have an idea what we want to see from you in the seminar topics, and afterwards we will continue with Swift, doing some additional features, and Philipp will talk a little bit about model view controller approaches in Swift. So, as a lecture topic, I chose, or as a seminar topic, I chose SpriteKit because it's very easy concept, and you already seen most of the concept in a programming language, so we can actually easy follow. So, seminar topic, SpriteKit. So, SpriteKit is basically a 2D game engine. It was designed from Apple, and you can create these awesome little 2D games. So, basically, a sprite is just the graphics, and you can place a graphic somewhere and can do animations and move them around and do some particle effects, physics, lighting, and all of these things are included in these things. So very simple framework, very easy to use, very high level in terms of like the abstraction from the graphic card. And this is a very simple game, and I will show you how to implement that game in a short demo where we will do the whole thing by having these particle effects in there, that doing the collision, doing the movement of the background and everything in a very short demo, and you can see that is actually pretty nice to use in a very simple way. So to show you a little bit of perspective of different graphics libraries that you have in iOS, and we have the different abstractions there. So this is basically the GPU, and this is your application, and I want to show you how these different frameworks fit into the graphics event one. On the first one, you have core animation, core graphics, and core image. These are the typical frameworks that we'll use when you just develop a standard application. So for example, if you use a drag and drop a button somewhere, drag and drop like a view item somewhere in the interface builder, you will use this graphics libraries from Apple. So they are basically included on. But you can also use them on your own. You can also say, I want to do some kind of image filter on top of these things, or I want to have a button that moves around with an animation, or a window should move in a certain direction or something like that. You would use these applications. We'll talk about these later on, but these are basically the graphics libraries that are support the standard UI, and they can do a little bit more. So, and they're usually 2D graphics and images. That's all you can do with them. However, they're somewhere in the middle of abstraction. So they are not really, you don't program something on a GPU, but you're not at that high-level API where you can actually say, I want to have the certain object and just move it from one point to the other. Similar, but not as that. So the second one is OpenGLES, which is now deprecated, but still you can still use it. And so this is the standard 3D graphics library that you probably know from all of devices. So OpenGL is basically supported by anything you can imagine. So this is the typical 3D graphics engine, which is already fairly close to the GPU, because you have to do a lot of command programming and think about buffering, storage data on the GPU, and send commands to the GPU, and maybe write some shaders and these things. And then we have Metal. I talked a little bit about this. This is fairly like basically what you do on the GPU side. You basically say, okay, this is my data, this is my buffer, and this is my shader, and the rest is done on a GPU level. So when you program Metal, you're very close to the GPU layer at all, because the good thing is it's ridiculously fast, because you can directly run stuff on the GPU. However, the bad thing is you have to do everything on your own. So basically, displaying a triangle and do a rotation with a triangle is a lot of code in Metal, because you have to set up the buffers, you have to define the normal variations, you have to create some kind of shader that allows you to do an animation, you have to have your own render loop that does the automation of things. So a lot of work to get something done. However, it's very powerful because it's very fast, and you can optimize that for your application. So if you're ever thinking about writing a real 3D game or AR game or something like that, you will probably end up with Metal, because that's where you have the most control of your device. And basically, if you look at modern engines like Unity or Unreal Engine, they are basically wrappers for Metal nowadays. So they're using Metal as the base layer, and they try to abstract that in a certain way. So, and then we have the very high-level graphics applications, and these are SpriteKit and SceneKit. SpriteKit is for 2D games, and SceneKit is basically for 3D. And here you have a very high-level abstraction where you can actually say, I just want to load that graphics, and this graphics should move for 5 seconds in that direction. So this is basically the application, how you develop this. So it's very abstract, and it's very easy to do. So, and we will focus on SpriteKit today, and SceneKit we will see later in the seminars from one of you to talk about this. So SpriteKit basically consists of objects. Objects can be any graphics you can like. You can just drag and drop in there, or you can just render boxes at the beginning, but basically you would take a designer who draws nice images and you just place it on objects. You have actions where you can actually define, okay, I want to animate these things, I want to have rotation, scaling, everything you can imagine can be done. And you can define certain time frames, you can concatenate them, group them, so you can have a lot of actions in a very simple way. And then you have physics. Physics is included, so you can actually say, okay, this should collide. So for example, the asteroid should collide with the ship, which I didn't do in this application, but you could do that and define certain variables of the physics engine, and you can actually define certain properties, so it could repel and all of these things. So a fully functional physics engine is included. In addition to that, you have lighting as well, if you want to do that. So you have lighting sources, so the typical stuff. And they're usually advanced doing new operations on these things as well. So how to program SpriteKit? Very simple. And the typical object that you have, so I will just show you a little hierarchy of this thing. You have your application, so this is the main window, so this is your phone. And on top of that, you have the typical view controller step that we already seen yesterday. So you have basic view controller, and you have an SK view, which is basically a UI view, which we already have seen, where we dragged on a button, but it's just a different class. It's a subclass of UI view, but it basically does the same thing with a little bit of extensions. And in this view, you have a full screen SK scene. This is basically your background. So this is the scene that does all the definition, all these things in you. So it has the run time loop. And what you're actually doing is, usually when you write an iOS application, you mostly do most of the code in here, because the view is just a viewport and you don't do a lot of view. However, in SpriteKit, you mostly do the code in the scene itself, because the scene defines what it's actually doing. And the controller doesn't really have a lot to do with it. The controller is just used for load this scene. And usually what you would do, for example, if you have a game, you have a starting screen, could be one scene where you have the menu in there, and then the actual game would be a different scene. You can actually switch them around. And you actually have nice animations like slide them in and stuff. So this is basically designed that you act, again, similar to the things that we saw yesterday, where you have multiple views for different stages. You can have multiple scenes for different stages, and you basically replace them. You can also say different levels could be a different scene. So to make the level a little bit more easier to understand. So how does the scene works? How does this scene works? It's basically based on a scene graph. So the scene is the root element, and you can attach objects into that scene. And as I did the example for our application here, so we have a lot of subparts. So the first subpart is the background. So it's basically one big rectangle which defines the background. And what I did at the background, I added these craters on this background. So they're basically inside the background, and they're animated so that it looks like the ship is flying in that direction. Then I added asteroids, so I did having flying asteroids on top of this background. You can actually define the depth information by having, it's a 2.5D application. You can define basically, say, okay, it should be on level 5, but you don't have any, you have not a normal frustum, but something that is basically a 2D game. And then I have a spaceship, and the spaceship has also some objects attached to that, the projectile and propulsion, so particle effects that produce particles on runtime. And there's actually a particle editor where you can actually click how the particle should look like, and you can just add them. And what happens, these are all a specific type of class, and this is called the SK node, and SK node is basically everything. You have a lot of subclasses, but you can actually address SK nodes on top of it. So these are all nodes. All of them are nodes. And what you can do for all of these nodes, all of them can have an action. It's called SK action, which is basically some kind of animation over time, or that can be influenced by physics. So you can actually define, for example, for the scene, you can find it should have a gravity. So everything that is physical enabled should be pulled in a certain direction. Or I could say the asteroids should be flying in one direction, and I can define what's the velocity and what's the damping over time. So for every of these objects, you can define a physics body, and this physics body follows then the rules of your physics engine that you define. So as I said, the main class is an skNode, and then you have a lot of different subclasses which you can use for different things. So skNode is subclass, and you have an skSpriteNode. The sprite node is basically a rectangle where you can attach an image to that image. So as I've seen, you have this asteroid, which is basically a rectangle, and just have a 2D image on top of that. Also for the ship that I have, and also for the crater. So rectangles with the graphics on top. You have shape nodes where you can actually define a certain shape using a Bezier patch or some kind of drawing thing, so it can actually not be a rectangle but a different shape. Labels for text, emitters for particles. Effects could be something that you can have some kind of image filter on top of these things. So you can have like Gaussian blur or something on your scene if you want to. So you can, as I said, or as you can see, the SK scene is basically a subclass of an SK effect node. So you can do, if you would like to just apply Gaussian filter to the scene, and everything in there would be then blurred in a certain way. And then you have crop nodes where you can crop parts of that. You can load videos, and there are a lot of different more for lighting, for camera, and for all of these things that you can imagine. So with this, to show you how it works, I will go through a little bit demo. I will not write the entire code on my own because it will take too long, but I will just undocument parts of the code to show what actually happens when we would write the code. So just to show you how it's currently looking in the application, so we have the scene, as I already said, and the scene has some variables which are not that important. And what I added here is just 2D graphics, PNGs, my asteroids, some crater, my spaceship. And what I have here is an additional class. This is called the emitter class. So this is basically an emitter running something like this. I can also have an explosion when I want to see that the shot hits the asteroid. And I have, this is my propulsion thing. And I can actually modify them with these lots of variables. So I could say, for example, I could say how many emitters should be created over time, in which direction they should fly. So when I change this, let's say I change that to 180, so we'll fly in a different direction. So you can actually modify or program your particle effects using this editor. And then you can just load this particle effect, and then it will do that constantly what you just defined. So for example, if I have an explosion thing, it will move in this direction. But I can also say, so this is currently exploding in every direction, but I can also define that it should be explode in just this one direction. So you see a lot of easy things that you can edit this. You can also define how large it should explode. You can actually say, okay, did the object should go bigger or smaller over time, how fast it is, how many particles are created. And here I can actually modify that on runtime in code if you want to, because all of these properties can be added. For example, for Thruster, I could say I want to collect a boost up, and to show that I could just create this, let's say, make this a little bit, let's see what happens. No, not really much happens here. But I can say I want to have something like this to show that my spaceship is now faster or something. So you can actually define that in your code in a simple way. So you don't have to deal with that by program that. For example, in Metal, you would have to program that entire thing on your own. So you would have to write a shader that does this constantly. So this is basically, you load a file, you define that file, and you can actually say, okay, I want to have a new file here. And this is, where is it? SpriteKit particle file, and this creates your file, and then you can modify that file in the way you would want. You can also define the color and everything like that. So let's go to the code. So what happens, first of all, we have to set up the application. Currently, nothing is, we are not seeing anything here. So this is what currently happens. Nothing, because I didn't have any code in there. So it's just black. You see a little indication here, how many nodes. You probably don't see it, but usually you see an indication how high is the frame rate currently and how many nodes I created in that scene, so you can actually see live how stable your application is. Again, the simulator is not the fastest one, so if your frame rate drops on the simulator, it doesn't mean it drops on your device. Especially for graphics application, you should most of the time develop on the device itself, because if I add in the simulator like 10 particle effects, my frame rate is gone. But on the device, it doesn't really matter, because the simulator cannot emulate the graphics card that well. So the first thing I will do, I will set the background to the gray color that we had. So basically, this is from the scene itself property, and I define a UI color where I set the values red, green, and blue. So this is the class which I can set. So the next thing I want to have, I want to load my spaceship. Let's do that. So what happens here is this call basically says, okay, I want to have a sprite node, and I want to load that image with that name that I just stored in here. So this is the spaceship, and I give it a certain name, because every node can have a name, so you don't have to have a pointer to that object, but you can ask your scene later on, give me that node with that certain name, so you don't have to think about, okay, what is currently my variable stored, but you can always ask your scene, give me my spaceship. I don't care where it is, I just want to have it because it is attached to my scene. Then I give it a certain position. CJ point is basically a tuple, or with an X and Y position on the screen. And I define a certain size, because the graphics is pretty big, and I make it a little bit smaller so it's actually visible. And then at the end, I have to add it to my scene, because the scene should display that object. So every time you set it up and you don't add it to your scene, nothing will happen, because you have to add it into that scene graph that makes it visible. So let's run this. So here's my spaceship. That's currently nothing happens here. So the next step is I want to set the thruster, so it should look like that the spaceship is actually flying. And here I have to load this emitter class. And as you see it, I use the guard statement because this initializer could fail, because it could be that the file doesn't exist in this case. So I need to have a guard statement and ask the emitter node to load the thruster file, which is basically this thruster, so you work with the names of these things. And then I say, okay, the position should be a little bit below the ship, because what I'm doing is I'm not attaching the thruster directly to the scene, but I'm attaching it to the spaceship, so it stays always connected to the spaceship. So you have these levels. And I set a little bit to -1 by the times of the spaceship height, so it's a little bit on the back. And I add it to, instead of here I add it to the scene, but here I add it directly to the spaceship. So I don't have to care about the position of the thruster, I'm just attaching it to the object directly. Let's see what happens. Yeah, so I have my little thruster here. Well, actually frame rate is still stable. Let's see what happens later on. And then I will set up something that I need later on. It's the physics vault. The physics vault is basically saying, typically when you enable, so you have to enable physics or not. And what usually happens that you have a gravity of -9.7. So the typical Earth gravity, so if you have a physics object, will be pulled down. So what I'm doing, I'm saying, okay, this is in space. I don't want to have any gravity effect, so I'm setting the gravity vector, so the direction in which every object that has gravity enabled should be pulled. I set it to 0, 0, so it should not pull in any direction. And then I say, okay, physics vault contact the delegation. It's a delegation method. We'll talk about this. But basically it tells me, okay, every time I have a physics effect, for example, a collision between two physics objects, this particular scene should be notified with a certain function that you have to implement. So, what this will be used for later on. So now, I want to move the spaceship. I want to drag the spaceship around so I can play a little bit without. And for this one, I need to implement this touch input function. And this is basically a function that you can that every view has. So it's an override, and it basically gives me every time I'm moving my finger on the touch screen around, it triggers one of these events. And what I'm doing here is now, okay, as I already said, I didn't store the link to my spaceship because I know it's my scene. So what I'm doing here is I'm asking my node itself, okay, give me the node with the name spaceship, because I defined that. And again, this is a guard statement because it's could be that the spaceship doesn't exist. And also saying, okay, I want to have just one touch, so it's another condition in my guard statement because I don't want to do multi-touch. And I want to have the position of my touch. And here I can basically ask for that position in that coordinate system of the scene itself. And then what I'm basically doing is saying, okay, my spaceship should have the position of this point. Basically, I should always warp to my finger. So I'm not doing basically a movement, so I could warp it. So let's see what happens here when I create this. Yeah, so I can move it around. And what I did here is basically I just used the X position of my touch. So I'm not putting it directly under my finger, but I'm just moving it on the X-axis. Because the Y axis stays the same in this case. So I didn't update that. Because I just want to move it around. So I can do this thing as well as here. Yeah, this is lagging now. But now I can actually move the spaceship. So what I want to do now is let the spaceship shoot something. Or, well, let's create first the backgrounds to see, where is it? So that you have the feeling that the spaceship is actually flying on the moon or something, that you have this movement thing. So let's create this function. Now I have to first enable this one. And this is basically a random function that gives me a random X position, so the asteroids does not spawn always at the same point, but a random point somewhere on the X-axis. So it's basically give me a random value with the width of that object, so I can have like this random X value for my things. And then I can enable my asteroids. So this is the create asteroids function here. And the first part is the same as I created the spaceship. So I load the sprite node, I give it a certain size, and I put it at somewhere on a screen size with a random X position and the top Y position. So it will spawn somewhere on the upper part of my screen, and then I add it to the scene. However, I don't want to do an animation by letting this move, but I want to use physics to let the asteroids fly in a certain direction. So what I'm doing here is, in this part, I'm using the physics property and say, okay, this should be a physics body of a certain size. And what you can do now here is you can actually define how the physics body should look like. In this case, I'm saying, okay, it's just a circle. I don't care. But you can also say, okay, I want to use the bit mask of that object, so you actually have the physics body is exactly the same of the graphics body. However, this takes computational power, so if you have a very simple physics simulation, you can just use like a rectangle or a squared object to make the physics calculation a little bit easier. However, if you want to do complex physics, you can actually say, okay, the graphic that I have, it should actually be perfectly matched to that graphic. So it takes an alpha filter and then creates the object around these things. And then what I'm doing is say, okay, the physics body should have a certain mass, and it should not have a linear damping, so it should not slow down over time, and it should be somewhere positioned above the screen, and the physics body should have a certain contact bit mass, which I will talk about this later on, and then I'm saying, okay, the physics body should have a certain velocity, so I'm basically flipping the physics, the asteroid in a certain direction. In this direction, I'm flipping it downwards, so it feels like they're flying in that direction. So let's run this. Yeah, okay, nothing happens because we don't call that function. How do we do that? And here I have this little function, and this is basically the render clock. This is the clock where you can hook into the application, and it's called every time a frame is created. So as you see, this is an override, it's an update function. So typically it runs, every SpriteKit application runs with 60 Hertz. So 60 frames per second. I think you cannot make it faster. The display is not faster, so you cannot really update it. However, if you do a lot of things, it will slow down. So if you have 10 particles effect, so my frame rate will go down dramatically. So what I'm doing here, I have a property which is, with this function, I'm just saying, okay, I want to have just 1 second every time I update that function. So basically, this allows me to say, okay, I want to have spawn one asteroid every second. by updating a variable and check if the delta between these variables is 1 second, and yes, then I can create this function. So let's create some asteroids. There's the first one. So they're flying in that direction. And I don't have to do anything. They will fly forever because I don't remove them, but I don't care. As you can see here, it's too small, but the node count rises. And the application at some point will have unlimited, too much nodes and will slow down. However, because what you could do is now say, okay, I'll check if the asteroids crosses the screen, and so I can remove them. So this could be optimized. So I have these asteroids. So the other thing that I had in my application is that I have these craters in the background that you have the feeling of something you flying above the moon and you don't have a static background. Let's see how this can be done. And this is similar to the, again, I'm creating a sprite node from my crater graphics. I give it a certain position, should be in with the background. Everything should fly above these things, so I give it a Z order. I give it a position somewhere, again, X random, and the size should be on top of the screen, and I add it. And instead of now using the physics engine, I give it a certain action itself. So what I'm doing here is I create this action class, and I'm using it as a move gesture, a move thing. And it should move to a certain direction. In this case, in vector, basically, it should not move on the x-axis, but should move for the length of the screen in 5 seconds. So it should do the animation in 5 seconds. You can define any time you want. You can also do this in a simpler way. And then I say, okay, move this. And what I'm doing then is saying, okay, I create a remove action. So this is not, when I want to remove that class again from my scene, I can use also an action and say, ask action remove from parent. So in this case, I'm basically cleaning up when the object has finished his movement. So now what I'm doing is I'm giving my crater, this what I just created, so the graphics, and let this action run. However, I now have two actions. I have the one action that moves the object, and I have the one action that removes the action. So I want to have a sequence. So basically, I give it a sequence of first move that crater across the screen, and when you're done with that action, remove it. You can also group them. For example, you could have a rotation or scaling action as between, and can say do it at the same time or do it in a specific sequence. And there are like 100 different actions that you could apply. You can say, okay, it should move in that direction, should move with that velocity. So the action class is very powerful, and you can actually apply that to different objects at the same time. And again, to make that work, I'm also spawning them with the random create asteroid function. And let's see what happens again. So, and this has the feeling that I'm flying above the moon and asteroids will hit me now. We have to think about how to destroy these asteroids. So how can I do that? So the first thing I have to think about how to create the shot that I want to do. And so basically what I decided here is to do it by basically not doing a button press, but doing it like in an interval. And this is this function here, and this is quite long because it uses physics. However, so basically, again, the first part is the same. I'm creating this particle effect, and I'm attaching it to my spaceship. Oh no, I didn't attach it. I attached it to the position of the spaceship, but to the scene. Otherwise, when I move the spaceship away, the object would fly on the x-axis as well. So, and what I'm doing is I'm creating this object, and now it's a little bit tricky because the particle effect, what I want to do is I want to let the physics engine decide when the particle effect hits the asteroid. So I don't want to do that on my own, calculate that every frame second, but I want to let the physics engine decide when the object collided. However, the particle effect cannot do that on its own because it doesn't really cannot be applied a particle effect, but I'm creating basically a small, tiny node which is basically displayed below the particle effect. So it's attached to the particle one, but you cannot see it because the particle effect is on top of this thing. And these are connected, so they're flying in the same direction. And they are moving using physics. And as you can see here, the physics bodies, and I define a mass, and I define a position, and I define a velocity again. So I'm shooting it upwards. And then I'm creating the particle effect in this way. So, and I have to create the shot again. So I'm using the same update function to call this. So that's basically what happens. So I can move it around. Yeah, it's lagging. Awesome. Oh, okay, physics is already enabled. So this is already directly enabled because I created two physics contacts, and the physics engine already does something. It looks pretty weird what it does, because now it thinks, okay, there's a collision, and the typical behavior is, okay, two objects collide, and they do some rotation things. So this is probably not what I want to do, because this looks weird. So what I want to do is, at that point, I want to say, okay, I want to have at the time where these objects collide, there should be an explosion and both objects should disappear. Because, yeah, I mean, you can already create a fun game with that, but maybe not this one. Yeah, totally realistic physics here. Okay, and for this one, I have to go a little bit back and define this function. So basically what I'm saying here, this sets the physics engine and tells the physics engine, every time you have a collision, give me a callback. And I can react to the callback. I can decide if I want to react to that callback or not. And here, currently I'm not. I'm just ignoring this. However, I have a function here which does this detection. This is the last function I will show you, and then we are done with the demo. So, and what it is a function that said did begin, and it basically says, okay, we have a physics contact. And the physics contact, so this is triggered when the shot hits the asteroid. And here, a physics contact is always between two objects, and this physics contact has this property body A and body B. And this is what happens. So you can actually tell, okay, give me both of these objects. And in this case, I'm just removing them from the parent because I don't want to use them anymore. However, you could also ask each object to say, okay, what are you? Are you the asteroid or are you the shot? And you can do something with the asteroid, for example. Maybe scale it down to make it like disappear, or let it fly in a different direction, or let it break apart, or something like this. However, in this case, I'm just removing that, and I'm saying, okay, I'm loading my explosion emitter effect, so this emitter effect that I showed you before, and then I position the explosion on the contact point where the physics detection happened, and I'm saying, okay, yeah, let the explosion run. And the nice thing about this particle effect is it has a certain lifetime, so it will disappear after a while. Because I didn't set it that it should be done infinite time, but I'm saying, okay, this particle effect just lives for 1 second, and then it disappears, so I don't have to remove it again. So let's see what happens now. So this is all. So we have this thing that we wanted to create. So this is the first glimpse into SpriteKit and what it can do. So I showed you a little bit of physics. I showed you a little bit of animation. As I already said, it can do lighting. It can do also electrical fields and a lot of. So it could actually create gravity fields that have a whirlwind around. So you have like some dark black hole effects. You can have electrical fields. So it has a lot of properties that you can use. So this is just a starting application. So, but it works very, very similar to what I just showed you. You always have these objects which can be used in a physics engine. Also you can use them, or you can animate them on your own, and then you can react to events. You can also have it's called. You can also integrate it with the how's that AI kit named, the gameplay kit? Gameplay kit, isn't it? Gameplay kit is some kind, you can actually create some kind of agents, so you can create entities that have a certain function, so you can combine that with some kind of knowledge system that allows you to create, like, for example, spaceship that fly for a certain behavior and do these things. So it can be integrated into different frameworks that help you to solve some logic issues of the game. However, this is just the graphics application. So this is the first, just a simple explanation. So something like that we want to see actually from you in your seminars. So giving a basic explanation of the framework, and then show like how you can use that framework. Show a demo, or in this way, I'm just including parts of the code because I don't want to write that because that takes very, very long. But maybe you can have a small demo where you can actually write some code, but we want to see, okay, what's the framework about? How can I use it? And how can we load it? So that, think about something like you would like to see from someone giving a presentation and tells me something about SpriteKit. So now you can actually watch the video again and run this or write this or check out how to do that in a simple way. Okay, but this is the seminar topic, and now we're switching back to the lecture. So today we're going to talk a little bit about protocols and extensions, and then we go back to a little bit of the table view controllers and dig a little bit deeper into how to create your actual applications. So Swift protocol and extensions. Protocols you probably all know from Java, which are interfaces in this case, usually. And protocols are basically some blueprints. So it's a method that is really not really implemented, but you can actually give classes certain behavior or assume that a certain class that implements a protocol behaves in a certain way. So similar to interfaces in Java. The problem is because in Swift you cannot like have your class cannot be a subclass of two different superclasses. So you cannot create the diamond of death, but you can also have to use protocols to have multiple functionalities in there. So, and protocols can be adopted by any type, so you can actually have structs follow protocols, so that's a new extension that Objective-C couldn't do. And it has a lot of like typical or standard protocols that you can just implement. And a lot of these functions, for example, the physics engine, where I said, okay, I want to react to a physics engine, I set my scene to be to fulfill a certain protocol. So this you will see a lot in applications. So, and I want to go back. For this one, and typical protocols are, which I will explain a little bit to show the functionality, is custom, string convertible, equatable, and comparable. So these are standard protocols that you can just implement and have functions like, for example, the equatable says, okay, you have a custom class that should react to the equal sign, so you can make sure a comparison between two objects. So, but let's talk about first the custom string convertible. So usually what you do if you want to print something, you get for standard values, you get the information that you would like. For example, for this string, if you print it out, it will say hello world. For the number, it will tell the number, and for the boolean, it will tell the value. However, if you have a custom class and you want to print it out, or you want to have a string for that, you usually get some information that maybe you get a pointer information, you get the name of that class actually. Here, let's say we have a shoe class, which has the color, the size, and has laces or not, and you have an initializer. And what would happen if you print that out? You create two shoes, and you will print that out, and you will get shoe and shoe, because how should the class know what you want from the printing? So it doesn't really give you a lot of information about the object itself. It just tells you, okay, this object is from the type class. And here, the first protocol is the custom string convertible. You can actually tell the system what should be happen when you print out that object. So it should have, you have to implement a custom or this description variable, and here you can actually say, okay, this description variable describes what actually happens when I call that thing. And this is basically computed property, and you have to implement that, and what happens then is you then print out my objects again, you get actually this description thing. So this is a very simple protocol which just implements this description, this computed property. Let's go a little bit further. So equatable, it's also similar. So for example, you want to compare two employees, and you don't want to compare the object because they could have the same forename or last name, but you don't want to have the same thing. And you can actually say, I want to have this comparison, if it's the same person I have. And here again, there's this functionality which you have to implement, and it's called, the protocol is equatable. And here you have to define that the static function that allows you to use the comparison operation just on your public class, on your custom class. And here you have to have the structure saying, okay, left, right, and here then you define, okay, when this statement should be true. And here I'm basically saying, okay, when the first name is the same as the first name, the last name should be the same, and the company ID should be the same. I don't care for now for these things, for the rest. So you can actually define when two objects should be the same in this case. And then you can use the same operation that you use for definition as well. So in here, then you can do the same operation again. Yes. What did I have here? Oh yeah, comparables. You can actually then also define, okay, I want to sort them in a certain way. I want to have like an order of them. Usually also for classes doesn't really work, because how should the system know how the order should be? So in which order should be ordered by first name, should be ordered by last name, should be ordered by ID, should be ordered by anything else. So the system cannot actually apply that. But you want to use that sorting operator, for example, for a string. And here you can actually do the comparable operation, which is basically define this sorting operation. So you basically say, okay, where do you compare these things? So I want to compare should always be sorted by the last name. And then you can use the built-in functions from an array or any other class that uses sorting operations on your custom classes. Yeah, this works very similar. So how can you actually create a protocol? So you cannot just apply protocols, but you can also create them. Very, very simple. And this is basically similar to a class or a structure. And however, in this thing, you use the keyword protocol, and you say the name of the protocol, and then you basically define what should be implemented in that protocol. So in this case, we have a protocol that says, okay, it should have the system or the class or the struct that implements my protocol should have the variable full name and should have the variable or the function say full name. So in this case, I implement that in the person structure, say, okay, I'm using this notation here, and then I have to implement that function. And here comes the tricky part. When you define a protocol and you let your structure follow that protocol, you have to follow the protocol. Because if you don't implement it, the compiler will say, okay, you don't follow the protocol, please do that, otherwise you cannot compile this. And here is a little tricky, which we'll talk about later on. I showed you before, I already said in the physics engine that I applied a protocol, but the function was not implemented. And there's the little tricky part between old Objective-C and Swift code, which we'll talk a little bit about. Because at some point, you don't have to always implement every part of your protocol. And these protocols are commonly used for delegation methods. So basically saying, I want to have an instant or a class follow a certain functionality. As I already said, the physics engine is something where you can say, okay, I want to react to a certain interface. But also a lot of different standard variations. For example, we will talk about table views, delegations, and you basically tell your class I should react on changes on my tables. So you basically have to implement these protocols in your function to get the callbacks from the GUI elements, or picker views, or from SpriteKit as the physics engine. So basically use this functionalism. So let's talk a little bit about optional protocols. As I already said, usually when you create your own protocols in Swift and you say it should have two functions and you have a class that implements that protocol, you have to implement that. Otherwise, the compiler will say, nope, the protocol is not followed. I cannot do that. However, there is a little bit of old stuff still in iOS, because iOS was implemented in Objective-C and is currently slowly transformed to Swift. So it will take some time, but basically UIKit and all of these standard libraries are still Objective-C code. And there was this concept of optional protocols, where you can actually define which parts of your protocol needs to be implemented and which part you can just ignore or just implement when you want. And in this case, basically, you have this protocol of saying, okay, this protocol, basically, you could implement that protocol for any class you have without having to implement these two functions, because they have this optional tag and basically say, my structure can follow that protocol, but the functions of that protocol are just optional. So I don't have to implement that function if I want or not. However, now it comes this little crazy keyword, which you will see occasionally. And what it basically says, okay, this object, this protocol is coming from not Swift, but from Objective-C. So basically, you create a bridge into the Objective-C world, again, where iOS is still at some places there. And you're basically saying, I want to have that optional functionality, and I want to use that. However, then I have to follow specific Objective-C rules, some which are a little bit different. Well, for example, an objective, that means that you have like what the class or the struct has to be a subclass or even a class of Objective-C. This makes it a little bit weird. For example, structs usually do not have a superclass and usually cannot follow Objective-C protocols because they are not part of the Objective-C class world. However, if you see, for example, the UI view controller, and these are all parts, so if you have subclass of a UI kit elements, they are coming from the Objective-C world, so you can actually apply UI protocols. You can also create them on your own. So this is one I wrote myself, so you can define these Objective-C protocols on your own, but then you cannot apply them to every structure you create. You have to be sure that the object that implements the protocol has some relation to the Objective-C world. Otherwise, it will just say, okay, I cannot follow that because I cannot be compiled in Objective-C. And this is the example that I used in the physics demo, in the SpriteKit protocol. So this is basically the header of that SpriteKit framework. Basically says, okay, I'm using the protocol physics contact, and this is from the type NS object protocol. So this is an Objective-C class. This means this is an Objective-C protocol, and I can use the optional function and say, okay, I want to react to the did begin contact. And as you see it in my code, I never wrote that function because this is an optional one. I could also say when I should react on these things. So you will mostly write your code in Swift. However, you will touch a lot of concepts which are still from the Objective-C world because a lot of the systems and the background of iOS is still written in Objective-C and follows Objective-C rules. So for example, UIKit is a good example where they start doing that. But there's now the first framework which is entirely written in Swift, isn't it? Swift. Core ML is the first one which is entirely written in Swift. Could be. So there are not a lot of frameworks which are actually written in fully on the Apple side on Swift. So they're starting to move to these things, but it will take some time to do that. So these are protocols. You will use them all the time. We will see them in graphics things. Yes?
In the previous slide, we had mentioned when we are using the Objective-C protocol, we mentioned Objective-C. Here we do not, right?
Because this is from the header file of the framework. And the framework is written in Objective-C. So this is from the Objective-C file. So this is not inside a Swift file. This is from an Objective-C file. So basically, this is written in a different language and is not compiled with Swift. So this is basically the header. You cannot change that, but you can have a look at it by checking it out. So basically, this is already Objective-C file. And this indicator basically says that this protocol is apart from this subclass. So this works as well. But if you want to do that, you have to use, when you write a Swift code in a Swift file, you have to use the Objective-C tag, because then you tell the Swift compiler, okay, this part should be now compiled with Objective-C, and the rest not. But this is in an Objective-C file already, so there's no Swift involved at all in this case. So you have to use that. So the next step I want to talk a little bit about are extensions. And extensions is basically a functionality where you can give an existing class, let's say your custom class, or any other class that already exists, or struct additional functionality. For example, I can say I want to have a string with an additional functionality that always puts like an H at the beginning of my string. So you can extend existing classes by using extensions in a way that allows you to use them on your entire code. So what, for example, you can say I want to have like a string should always have a new function. Let's say string should have a property that tells every time I call it is name, and it should always return Philipp or something like this thing. So this is something that you can do, and you can actually do it on your custom files, on your custom code, but you can extend existing codes, for example, string or any other class with these functionalities. However, you can basically, what you can do is you can create computed properties, you can add new functions, you can new initializers. For example, if you ever use a certain initializer of a class, and this is too complicated for you because you always call the same thing, you could create a custom initializer for that particular class that makes it a little bit easier for you to use. And you can also say, okay, my class should follow a certain protocol I just implemented. The string class should follow a certain protocol that I just defined that has some functionality, so I can use it. However, the difference is you cannot add properties to to an extension, to a class. Because this is due to the compiler set, because let's say you have the string construct that you have, and the compiler cannot create a larger object of that because it already has a certain byte size, and you cannot do that on runtime, add some things there. There are ways to attach certain objects to this, but this goes a little bit far. Let's say for now, you cannot add properties to these things. You can add computed properties, so they are computed on runtime, but you cannot make the byte container of that specific object larger because it was pre-compiled and you cannot do that on runtime. So you couldn't say, okay, the string should be now 10 bytes larger. So this is a certain limitation that you have, but you can easily add. So how does it look like? So the extension is again very similar to classes. It's the keyword extensions, and then you name the class that you want to extend. In this case, I'm using the UI color. UI color is a class which can be just encoded color format, and you have a lot of different properties that you can use. And I'm basically saying, okay, this is my variable that should be a static one. So that's why I can create this, because statics ones you can create because they're not attached to a certain instance of an object, but to the entire class. And it defines my favorite color, and it should be always I don't know which color this is, some greenish, whatever. So with this, you can actually extend this thing. And now in your entire project, you can use the UI color and use that variable without having to include everything. So every extension that you create work on your entire code base. So there's no scoping, nothing at all. Every time you can call that class from everywhere, you can also call this functionality. And this is something that you usually do to extend this. For example, you could say, I have my struct employer from before, and instead of writing this function directly in the struct itself, I'm writing an extension that extends my struct with this certain functionality. So basically, I'm extending my employer, which allows me to use this protocol. And with this, you have a nice way to separate your code file into different parts. And you see a lot of developers who actually do that constantly. So every time they define a new protocol which does not provide any new properties, they say, okay, I'm writing this in an extension because this separates your code in a nice way, and you can actually separate it into different files if you want to. So that does not have to be in a single file. So this is what people will do that to make it a little bit more understandable, because now, this extension is just to make sure that the equatable extension protocol is fulfilled. You can also write multiple extensions. Now you could say I want to have 10 different extensions. So there's basically no limitation, except you have to make sure that you don't write the same thing again, because then the system would be confused. So extensions are something that allows you to make function more useful. Usually I write a lot of string extensions to make some comparison between different strings a little bit more easier. Or for SpriteKit, you can do extensions that allow you to create specific nodes which already have a certain set of functionality. Or you can extend, say, you don't want to set up the physics body all the time on your own because you know how it should be set. You can create a physics body extension saying, okay, I'm setting those properties directly in the extension and initializer, and I just have to have, instead of 10 lines where I define something like the mass, the velocity, and all of these things, I'm using just an extension to that physics body that tells me, okay, set this up in my way, this I already sent it to. So it can reduce the part of your code in a nice way. So this is the part for today for Swift and the seminar, and Philipp will go a little bit back to UI view controllers and storyboards and how to write these things.
Yep. So view controllers are usually the things that handle what you see on your screen. And there are a lot of different ways how you can combine them, attach them on your phone. There you go. How you can combine them and structure what is shown or in what sequence they are being shown to the user. And the thing we've talked about, I think, yesterday was navigation controller. So that is, I have one main screen, and if I tap some button or whatever, I'm switching on to a next one, and I have there in my title bar the option to get back. So it's a linear sequence of view controllers. And you can mix them, so go into different directions and stuff like that. But it's all a sequence. The tab bar controller is something that is a little bit different. So you might have seen that the bar here at the bottom is basically giving you a couple of different options, different things you can look into. For example, on the iPhone, you have the clock app where you have the world clocks in there, or a timer, alarm, stuff like that. And those are all different view controllers that handle then what is shown on the screen, but they're not in a linear fashion. So whether I'm selecting here's a near me or top chart, search, or whatever, they are not in a linear sequence. And I can just select those and switch between these different view controllers, different interactions I want to do. And to create a tab bar controller is similar to what you have with a navigation controller. So if you already have your one view that you started with, you can say, okay, embed this in a tab bar controller, and in the storyboard it will immediately pop up that you have, similar to the navigation controller, a starting view controller with the tab bar, and then already connected your original view controller. And that will then automatically add an icon or a button here in the tab bar that you can select to switch to that view controller. And if you want to have multiple ones in there, just from the tab bar, you can attach a new view controller to embed into that. And again, it will automatically just place an icon down here. And you can specify those icons. There are a set of different options you have from the start. So whether you have favorites, charts, location information, and we'll take the icons directly, or you specify a custom one that you can just say, yeah, I want to have a red button or something in there, and it will place it inside. And as you can see here, I mean, this has now 5 view controllers attached to that. But you can, basically, there's, I think, no limit what you can attach to those. But it would get very crowded there in the bottom half if there are 10, 15 view controls in there. And again, it depends on the device you're using. If you have a smaller device, then it gets problematic more quickly. And so what automatically happens if you have, I think now if you add a 6 view controller to that, the last item here will automatically switch into the 3 dots and just saying more. And if you tap on them, then you have the remaining view controllers that you can choose from. And you as a designer can choose the option or the arrangement of the buttons down here. So what should be always visible and what is hidden behind the more button. So since I can switch between these different elements here and have my different information on the screen, those are all handled by different view controllers. And how could I now, as the developer, react to that? How do I know what is shown, what is currently visible? And each view controller has this life cycle, and it has just a couple of different states that a view controller can be in. And the main parts are that it's, well, not loaded, being on the screen, or being not on the screen. Those are the 3 main parts. And between every transition between these states, you have a message that you, as a developer, can react to. So for example, when you start the app, no view is currently loaded. Or if I have my tab bar set up, the other views are not automatically loaded, because if the app would start to put into memory every view that could possibly be reached through your app, will increase the memory and will get messy very quickly. So views are only loaded if they are being used. So if they're first time being used, or if there's a sequence that ensures that this view will come into play, then the app will load that view. And currently, we often put the code that we wanted to set up the view or the elements in the view with in the message view did load. Because that is the first time you know, okay, everything is set up, my outlets are connected and stuff like that, so I can react to this information. Yeah, it will. I can now set up my stuff. And often what will be done in the view did load is setting up database connections or network connections, stuff that you want to prepare, that once your view is actually being shown, you can react to those information. Then the view will appear is immediately called before your view actually appears on the screen. And that is something where you can then get the information from the database or get the current location of the user that you then want to show on your map on the screen or whatever. So get the up-to-date information that you want to show to the user once it's being seen. Then when the view appeared on the screen, you get the message view did appear. And stuff that you could do in that is if you have an action that takes a little bit longer, so it is not immediately there, the information. If you start it there, you can show a progress indicator. Okay, now I'm getting that information without keeping the view from actually appearing or blocking the whole system. So starting information there, showing, yeah, I'm receiving that data and I will show it to you once I have it. And then when a view is being removed or another view is being shown, so for example, in the tab bar controller, if you select another icon and I'm switching to another view, then the original view will receive the message view will disappear. So what you can do then is react to that, store data or disconnect from databases, stop location updates or whatever. And then when it's actually not on the screen anymore, you also get the notification, okay, now it did disappear. And that is essentially the circle that there is. When the app decides, okay, I need to free up memory and you haven't used this view a lot, then it also will switch back into the not loaded state, but it should not affect you as the developer at that point, because once the view is loaded again, then you get the notification, okay, view did load again, and everything should be set up, network connections and stuff like that. So that is for individual views that you have and the messages that the view controller has. And similarly, you have also for your whole app similar notifications that you get. And they correspond to the application lifecycle. And the application can only be in these five states, while not running and suspended are quite similar. So let's say 4 states. So the app can be not running, never started, you just downloaded it, for example, and it also has no background tasks running or stuff like that. So when you then tap on the app, it will switch into the foreground. And the foreground has these 2 states, inactive and active. The inactive state is just the very brief state where you launch the app and it's starting to load everything. You can already see it, but it doesn't receive any touch information at that point. And then it will switch over to the active state. There's still information that tasks it can do, so query data and stuff like that, but the user interaction is generally disabled. So then when it switches into the active state, that is really, okay, your app is now the central focus that you have on the screen. The user can interact with that. It gets all the resources that it needs and has the priority execution. when the user then switches to another app or closes this app, or if some other interruption comes in, like a call on the phone, then it will traverse back into the inactive state and switch to the background. Now, in the background, it is still possible to execute code, but it's only for a limited amount of time that you have. You have roughly 5 seconds, I think, that you can still do stuff like, okay, storing the data that you needed to save, and close connections and stuff like that if you don't need them in the background, because then it automatically, the device will switch it into the suspended state, where, yeah, your app might have still the information, so when it starts up, switching back to the background and the foreground state, that it can resume what you were already doing, but it doesn't receive or doesn't have any capabilities anymore to execute stuff. Occasionally, they will just switch from a suspended state into the background and back. So if you have some notification setting set up, or the app is allowed to do something in the background, then occasionally the system will wake that app up, give it the background state that can do some information there or data processing there, and then will shift back into the suspended state. So, and to react to these different states, or these transitions between the states, we have the application delegate file. And that file, when you start an app, it's also directly set up. And it has these different functions in there that you can use to react to these certain changes. So did finish launching, the first one here, is actually the first time where you can execute your own code. Everything before is done automatically, and this is now the time where your code can be executed. Then will resign active is when your app switches to the inactive state and will head out to the background state. So that is something where you can react to, I know that I know will come to the background, let's prepare everything, and then do the storing stuff when I'm in the background. And there you get the notification that the application did enter the background. So you can react to those information there. Similarly, will enter foreground is something where it switches from the suspended state over the background into the foreground state, or when you start it first, that you get that notification, okay, now it is displayed on the screen. And did become active, similar to the will resign active. There, you see they always have these similar namings and 2 messages for each event that you know, okay, it will happen and now it did happen. And that is something similar. Application will terminate is then also, this app is closed down and, or will close down, do everything that you want to finish, and then it will go into the suspended state. And did enter background and will terminate, usually you won't use them together because one can be achieved by the other. You will most likely use did enter background if you actually have an app that does something in the background or needs to be woken up again to react to stuff, and you want to do something there in the background, while will terminate is usually if you only care if you're active and in the foreground, but you don't care when, or you don't have to do anything when the app is closed down. Are there any questions about the view controller lifecycle or the application lifecycle at that point? It's a good practice if you want to do a coding exercise. Go in and write just print messages in each of these for each of these calls. Also for the view controller, that you can see, test out when is stuff actually loaded, will become active, or will resign, and stuff like that. That you can have a brief look into that and see when is what called and in which order. So far we only had information there on one screen and everything fit into that, and you laid out the screen in the interface builder, and yeah, everything fit in one screen. But that is usually not the case for everything that you have. And a central part for that to show information that is larger than one screen, scroll views are very important. And scroll views, they are also the superclass of a lot of different UI elements. So for example, an image view can be or is in a scroll view that you can zoom into that and scroll around in the image. And it's also, for table views that you have a list of information and you scroll through them, also a descendant of scroll views. And to understand how a scroll view works, there are two properties that are very, very important. One is the frame property that basically specifies where on the screen is my scroll view and how large is it. So here you can see, for example, the scroll view frame width and height is now set to the size of the whole screen in there. And the content size property is actually then how large is the information that is inside my scroll view. So, and that is, as soon as it's larger than the frame of the scroll view, it will automatically be able to scroll through that. So in this case, while the width of the content size has the same, I don't have that installed, no, the same width as the frame, it won't scroll horizontally, but since it's a little bit larger here in the height, that means you scroll vertically through that. And the content size is actually something that I think it's still not possible to set it into in the interface builder. That is something you set programmatically, or you have to attach it to something that dynamically changes its size and is connected to the content. And to set it in code, you just set the content size property of your scroll view to, and very often you do it setting it to the frame of another view that you embedded in the scroll view. So you're creating a view that is much larger than the screen, and setting that as a subview of your scroll view and setting the content size automatically leads the system to display these scroll bars that you have there on the side. And since I said if you connect something that is dynamically changing its size to that, it also works. An example of that is the stack view that we talked about yesterday. And the size of the stack view, if you don't attach it somewhere on your screen that you say it should be full screen or stuff like that, the size is defined by the content. So if you have, it won't resize the elements, but instead adjust its size to what is in there. And that means if I have a stack view embedded in my scroll view, you can see here, then the size of the stack view is the content size of your scroll view. So if I enter a lot of information or a lot of labels with, you can't see the text fields also there in here, and it gets larger than the screen, the scroll view also is larger than, and I have here my scroll bars that I can go around, and I don't have to do any manual linking up in that case. So, but what would happen now if I have one text field here and I select that? The keyboard will actually just go on top of the scroll view and will obscure what is behind it. I could type, but I wouldn't see what I was typing because it doesn't automatically scroll further down. And won't get into details how to react to when a keyboard is shown. You can take a look at the book for that. There are a couple of messages that you can listen to and react to that. But how you would react is by setting the content insets. And that's basically the padding that you have from your container view to the view inside. So, for example, if I could set content inset at the top or bottom, and that means on the top and bottom I have a little bit more space that it will scroll through, even though there are no information set in there. And that can be used, for example, if I notice, okay, keyboard will now show that I create my content insets, and those are typed the UI edge insets. And the order is, what's the order? It will show up if you call it in Xcode, tell you which one is top, left, bottom, and right. So 300 apparently is the bottom. And if I now set the content insets to these edge insets, again, our projector, very bad. The whole screen is this size, but this area is then still scrolling down, and you can see here the scroll bar that I can scroll down. So now if the keyboard would actually show, my whole view would slide up, and I could still see where I'm typing because the bottom area is still empty. But since this scroll bar would look weird if I have my keyboard and the scroll bar essentially behind it, and would look like I could, or I'm scrolling through the keyboard. I can also limit the place where the scroll bars are shown also to those content insets, meaning it looks like the scroll view just ends there, even though the whole thing is a little bit larger. And yeah, similar to everything, every view that we've so far talked about, or what we also will talk about, is that the scroll view also has a delegate. And so it's notifying its delegate about different actions that happen with the scroll view. So one of the protocol or the delegate actions that are called is whether the scroll view did scroll to some place. And you get the information then to what, or you can query the information, what is now the new position. So if you want to react to something that is happening at the destination, that you can set that. The view for zooming actually specifies, if there's the zoom gesture, what subviews should then actually be scaled, or what should be zoomed. So if you have an image that you can specify, this image is being zoomed in, but maybe not a different one. So you can specify that. Did end scrolling animation. So you can see if you just quickly scroll through a list and you let go, then the system already knows where you will end up, but you still have an animation that shows you how to get there and starts slowing down and then stops. And you can get a notification when that animation did finish. Similarly, you can get an information when it actually starts slowing down. So why you would react to that, I'm not sure. I don't have an example at the moment, but yeah, you could if you want to. Or if there's just a touch and starting to drag up the scroll view or moving it around, you get a notification once that happens. And based on what we now talked about, you might already see that in iOS it's very often that the MVC patterns followed. Model view controller, anyone who doesn't know what model view controller means? Has never heard of that? All right. So it is something that is deeply enforced also in iOS, that you have your model, you can have different databases or model classes that you connect to, and every time you drag something in your view, that is then connected to a view controller that specifies how to react or connect the model with your view. So the view side is generally in the storyboard where you set that up and you connect it to a view controller that you can then react to or specify what should happen. And keep that in mind when you look at at your seminar topics. Where is there really the connection? How is that set up? How does it fit into this pattern and how it is enforced there? Any questions about this? Because then we're done for today. If you don't have anything, no. There are in the for the book that we're basing this on, there are a lot of playgrounds that are that you can download from the website. I think then the first. Oh yeah, we'll put a link somewhere. And those playgrounds are very good to get a feel of the language because they're essentially step-by-step tasks where you, create a constant, create a variable, change it, whatever, really test it out for yourself. But they go beyond that and have some more stepwise setups where you can create your own classes, have to call them, and stuff like that. Really practice it, get the feedback, and get the explanations of what is happening there. So especially if you have never used Swift or iOS before, take a look at those because they can really help you get a feeling, because programming is not something you learn by listening to us here, but you have to actually do it and get a feeling of the language. All right, then see you next week.
This content was provided by RWTH, Aachen University.